Hey everyone, we're going to order our functions from slowest growing to fastest growing as x approaches infinity. We're going to explain using limits, and we're looking at these conditions here. So let's first compare e to the power of x to x to the power of x. So we'll just take the limit as x approaches infinity of e to the power of x divided by x to the power of x. Now this can be rewritten as the limit as x approaches infinity of e divided by x all to the power of x. Now this as the denominator gets larger and larger here, this is going to go to 0 because e is a constant. So this whole thing's going to equal 0, or 0 to infinity is still 0. Since it's 0, that means my denominator is growing faster, so e to the x grows slower than this. So basically, our orders so far, we have e to the x grows slower than x to the power of x. All right, now let's go ahead and compare e to the x power to this next one. So x approaches infinity, we'll compare e to the x to ln of x to the power of x. All right, so let's write this as the limit as x approaches infinity, and then do the same thing we did before. Write this as e divided by ln of x to the power of x. Well, this also goes to 0 because the denominator is going to get much smaller. The denominator is going to get a lot larger compared to the numerator, so that makes the whole thing smaller, get closer and closer to 0. So the next, we know that e to the x is smaller or grows slower than ln of x to the power of x. Now let's also compare e to the x to the next one. So that's this e to the x to e to the power of x divided by 2. Now this is going to equal the limit as x approaches infinity of e to the power of x divided by 2, because this is e to the x power minus x divided by 2. And this gives you e to the, you can just write this as 2 divided by 2x minus x divided by 2. So that gives you that. Now that goes off to infinity. So that means e to the x grows faster than this. So e to the power of x divided by 2 grows smaller. It's slowest growing. Now let's compare those two, because we don't know what order those two go in. We do know that the first two are in the correct order. So let's compare x to the power of x with ln to the power of x. So for that one, we're going to have the limit as x approaches infinity of x to the power of x divided by ln of x to the power of x. Now again, let's rewrite this as the limit as x approaches infinity and pull that x out. All right. Now this also goes to infinity because we can differentiate this using L'Hopital's rule. Let's write this out and differentiate our x divided by ln of x. So let's take that off. So now using L'Hopital's rule, that would give us 1 divided by 1 divided by x. Okay, and this can be simplified to the limit as x approaches infinity of x, which, because you can just pull that up there. So that equals infinity. All right, Now, that tells us that x to the power of x grows faster since we went to infinity. So f of x grows faster, the numerator grows faster. So in order, this would be the slowest growing is e to the power of x divided by 2. Then we had e to the power of x. And then the next one is ln of x to the power of x. And the fastest growing is x to the power of x. So that's your order right here. Thank you. Have a nice day. Bye-bye.